All right, so next up, we've got to put the hole in the end of this guy. And you'll notice that it's not centered. So, and since we're drilling a bigger hole, we're not going to want it necessarily symmetrical. So I'm going to try and find a place where it maximizes the strength of this part, because the way they've got it now is a little bit problematic. And it's an interesting observation. This end cap piece is held on by tiny little screws. They look like 172s or something like that. I haven't seen Allen screws quite that small before. All right, so I've got the part just clamped in the vise. You can't clamp it too much or you're going to cause it to buckle up. So I've just got it snug in the vise, and just checking with the square here to make sure that it didn't tilt up in the vise, because there's a lot of mass out the back end. I do have a jack under it on the other side, and it looks like we're good. So I'm going to try and center, well, put the cutter where I want it, because it's not going to be centered. Centered would be here, and the original hole was not centered to begin with. They had it offset, which is unfortunate, because this support hole here is not useful for anything right now, and certainly won't be after I'm done. So we're going to bias up to this side. I almost feel like welding a plate on the outside that will add some more strength to this, because this is only 1/8 inch material, but we're going to try it like this first. So there's a little bit of a run out in my annular cutter holder, which translates all the way down this long shaft into a little bit of out of roundness at the end. Fortunately, the brass bushing that's going to go in there will take that up, so hopefully we'll get a decent cut out of it. I just eyeballed this to where I want it. That's a 1, and I think I need to pop out that piece. There we go. And that's it. We are through. One amazing thing about the annular cutters is that they don't throw up much of a burr when they're cutting through. There's a tiny one. Barely feel it on the bottom. Nothing on this side, nothing on that one, and nothing on that one. Very impressive. Do a surprisingly good job, especially when there's a hole already existing that you might intersect and it still didn't have a problem with it. It's very impressive. All right, next up, we'll make the bushing, 2-part. So we have a sizable chunk of brass loaded in the lathe here. This is to make the bushing. This is 2-inch diameter, and I have cut off a 1-foot section. Prices have gone through the absolute roof on brass, at least locally here. Copper prices quadrupled, and the brass, this probably would have been a $50 piece before. It's over $200 now locally. So we're going to try not to make a mistake here. So first off, we're going to face this guy, and then we're going to drill a 1-inch bore down 4 inches into this guy, and that will be for the center down the bushing. I will say one thing, brass really is beautiful to work with. Look at that surface finish when it cuts. I can see why a lot of people like Click Spring. He uses brass as much as possible. It just finishes wonderfully. To speed things up, we're going to take and do a 3/4 inch drill bit down to 300 RPM. Whoa. Yeah, maybe we will bore this. I know with brass it can grab, so you're supposed to dull the edge of your cutter so it doesn't grab like it just did. Well, we can try it a lot slower, but I don't think that'll fix the grabbing problem without me modifying the drill bit. Nope. Okay, so we'll bore it. Kind of crazy. I have a 1/2 inch boring bar that will go 4 inches, which is crazy high for such a small diameter bar. I think I've got to be very careful about chatter. Although since I'm going for an inch, I guess I can suffer some chatter at the lower diameters and then switch to a larger diameter boring bar. By the way, this height gauge has been working great for me for years. I know a lot of people have other ways to do it, and I don't have any problem with that. It's just worked really well for me all these years, so I continue to use it. The idea was originally taken from Joe Pyszczynski. I may have to slow it down a little bit because of chatter. We will see. We're heading straight up from 1/2 inch to 3/4 with one bite, which is admittedly pretty big. So I'm manually dampening the chatter. This is a ton of stick out. I'm probably going to end up taking like a pound or 2 of brass out of the middle of this thing. Such a waste. Switch to a larger boring bar. Our problems seem to be getting solved, although chip evacuation is a little bit of a problem. Because we're going to be packing chips at this rate. I wish I'd caught it on camera, but the boring bar on the first piece, as I was almost done with the final measurement, I tried to bring it back, but it caught a burr and it sucked the boring bar and pulled the whole tool post at a slight angle. And then when it came out, it damaged everything and I had to remake the piece. Now, with this one, we have a piston fit, which is great. So we can move on to the next stage. All right, so now that we've got the bore done, we need to remove most of this material down to 1.5 inch outer diameter, which will leave a 1/4 inch wall, with the rear having a 3/8 inch wide flange on it. All right, so let's start with 150 thousandths depth of cut. I don't think I'm honestly gonna need a center in the end to support this, but if I end up needing it, I'll add it. I think it's gonna be good enough. And there wasn't any noticeable deflection. When I measured here and here, it was within 1/10, so I think we're good. That's 1.5117, that's a little bit much, I think. Yeah. Yeah, it doesn't start. Hey, that's what we're looking for. Jeez, it's hard to align this. There we go. That would be perfect. Next up, we're going to part this guy off, leaving some extra on the end to remove. And we are good. Okay. Now we can flip this around and face it to width. All right, we flip the part around. Just need to take a little bit off. Put some frog tape on the back there so that the jaws wouldn't mar up the brass since it's so soft. Just taking this to size. And we're just going to polish up that outside edge with some Scotch-Brite. And this piece will be mostly done. We still have one more step after this. So I've changed my mind about how I was going to do the other side, the stop or the keeper for this guy. So my solution for keeping this in is I'm going to make another 3/8 inch bar on the other side. I'm going to drill and tap it for 1/4 20 set screws with a conical point. And then I'm going to drill a hole slightly, well, I'm going to put a conical point on this side, or groove, that's slightly offset by 10 or 20 thousandths so it can pull it in. And that way it'll be able to pull it up tight against the outside, and there shouldn't be a ton of force on this anyways. Everything should be rotating free inside here. So waste not, want not. That piece, the first one that I screwed up, where the bore is 1 inch 10 thousandths, so it's 10 thousandths, so it bangs around like a BB in a boxcar to my eyes. But I need a 1.5 inch center hole. So we're just going to reuse this piece and make our end piece, and then we'll head over to the mill to finish this up. So for this guy, we just need to bore it to 1.5 inches. Let's see what kind of fit we get here. Good fit. I'm going to part this guy off and head over to the mill. All right, so you can see from the setup, I'm using the locking ring in the back as a spacer to keep this thing parallel, because what I'm going to do now is put some datum flats in it so that I can actually find my perpendiculars so I don't screw that up. And so I'm going to first machine this one and then come down and machine this one, then flip it 180 and do the same thing by putting the flats on the bottom. All right, there's my first flats. I just machined the first side. I'm going to flip it 180 and do the second. Okay, I'm going to put my second set of flats here, rotate it so the flats are on the bottom. Just going to come and do another 20 thousandths. All right, and we're done. All right, so next up, we got a spotting drill here, which has the same angle as this conical point set screw. And here's the interesting thing. So the spacer that's sort of holding this side up here, it's actually proud by 20 thousandths on this side. So I'm going to drill it both holes dead center for the point, well, dead center of 0.375. So this one will be over 0.1875. The other one will also be centered at 0.8175, which will put it 20 thousandths this direction. So when I tighten that set screw, it's going to pull it that direction 20 thousandths, which should pull it right into the side of the jib arm piece, which will make it nice and snug, so it'll tighten itself. And since these are the same angle, I originally was just going to drill a sort of circular hole, but that would only make the contact at a line. With this method, it's actually going to make contact on a ramp, which is better and it'll be stronger. Now I just need to flip this 180 and do the same thing on the other side. And we're done with that piece. So if you want to see what I was talking about, here's the set screw, the conical point set screw. So if it's offset this way and I tighten it down, it's going to pull this whole part in this direction as you tighten it down. So it's off by 20 thousandths, and that should be more than enough to pull it tight. All right, so I'm going to drill and tap the next one with the same exact positioning, and it should be right on the money. Now, I know it would be stronger if I flipped this 180. I'd have to recalculate my dimensions again, which I could do. I'm hoping this feels pretty darn sturdy in here. There shouldn't be a ton of force on it, so we are going to drill and tap. And that's a 1. Do the other side, rinse and repeat. All right, so here's the piece. So you can see this is bored out now on both sides, all the way through for the larger size. And I believe actually this is the top. I believe it's offset that way. So now this guy with the dimples, I'm going to put it in this way so I can see it. It's a close fit, so it's a little snug to get in. And this guy with the pointed bits goes on here, and since it's such a close fit, you have to get it on really straight or it doesn't go. Here we are. And I know the flats are oriented, so I can sort of rotate this to get the flats right, but it pulls itself in also. See, you see it correct itself? And it also pulled this so that these are flush, so it took that whole 20 thousandths. And I'll tighten the bottom one over here. And this thing should be very, very secure. Now it doesn't rotate anymore. It's nice and tight. Here's the bar we made. And it also is a really close fit. So I was knocking everything over. You have to get it dead on straight, but it spins very freely. Nice and smooth. And then these guys will go on either side of the weight supports here. And then the weight supports go here, then another one of those. Let me bring the weight supports over. All right, so here's one of the weight supports, followed by another one of these washers and one of these locking rings, just to keep the bar positioned properly. And same on the other side. Everything is a fairly close fit. And another locking ring. All right, so here are all the parts together. And when this guy's up, these bars actually hang down. And through here goes another bar, a couple 50-pound weights in the middle and some more 50s on the outside, plus some smaller ones to get the counterbalance of the arm right. These arm jib systems are designed to have adjustable length arms, so they come in sections. I think they're 3-foot sections, and you can keep adding them up to 20-some feet out there. And so when you do that, you need more and more weight. This top bar here needs to rotate because the controls are on here. Some operators like the controls to float free. Some like them to be fixed relative to the position of the jib. So we had tried to address that as well. And this was a very interesting project. Here's the jib arm, and you can see the individual sections. You can add more to make it longer. And there's the rear disassembled, with the parts I just made waiting to go on. On the floor, some weights for the counterweight. Hopefully I'll be able to show you an assembled shot of the jib right here. Thanks for watching. Hope you find it useful. Hope to see you next time.